So we are looking at this differential equation, and first order differential equation. Now the first thing you look for is actually if it's separable. We can see here that it's not, and that is the form, the general form for a differential, first order differential equation, where you could use the integrating factor method. And just to be clear, P and Q are not constants, but functions of x. So we divide through by sine x, then I have a y by dx minus cot xy, because cos over sine is cot, is equal to sine of 2x. Now the integrating factor, let me remind you, is equal to e to integral of p dx. To be careful here that the coefficient of y is actually, or the term in front of y is actually minus cot x, not cot x, because there's a minus there. So you have to be careful there. So this is equal to e to the integral of, let me take, I'll write that in actually, minus cot x dx. Now, the integral of cot is simply ln sine x. That is e to the minus ln sine x. And of course, we know the rule, the minus 1 can go up, and that's sine x to the minus 1, which could also be written as cosec x. Therefore, my integrating factor is equal to cosec x. Now that I have that, what I do, remember, is to multiply every term, multiply through by the integrating factor. So to continue, if I multiply through by my integrating factor, I have cosec x dy by dx minus cosec x cot x y is equal to, I'm just going to call that sine of 2x over sine x. Is that all right? Yeah. Sine of 2x over sine x. And we know, now here's the key idea, we know that the left-hand side becomes an exact derivative. Okay, and we don't even need to think. We know that our integrating factor and y is what goes inside the bracket. Does that, what do I mean by that? I know that d by dx, once you've correctly found your integrating factor and multiplied through by the integrating factor, then I know that cosec x, y, when I expand this, when I multiply, when I find the derivative of this, okay, implicitly, implicit differentiation and the product rule, I will get exactly this line here. Okay, so you can check the maths yourself. So at this stage, you can see whether you've done it right or not, because, well, this is just the product rule, isn't it? U, V. Okay, so it's u dv by dx. Well, v is a function of, it's y, so So it's going to be cosec x dy dx plus v, which is your y, times du by dx. And the derivative of cosec x is minus cosec cot. So we can see, okay, now what goes inside the bracket is very simple. It's your integrating factor times y without thinking, okay? But it's a good check to see that once you put that in, you can do a quick check in your head to see that when I actually expand this out, when I find the derivative of this, do I actually get this? Of course you do, because that's the whole point of the integrating factor, is to make this an exact derivative. What do I times this by to turn it into an exact derivative? And that on the right hand side. Now, I'm not going to waste too much time, but sine of 2x is 2 sine x cos x over sine x. So are we happy to call that 2 cos x? Now, if you're not sure, please see the video on trigonometric identities. So the next step, therefore, if I integrate both sides, on the left-hand side of my equation, I'm left with cosec x y is equal to the integral of 2 cos x dx. So cosec x y, now the integral of 2 cos x is simply 2 sine x. Okay, so now to make y as a function of x, because the question wants in the form y equals f of x, y is there. So if I multiply both sides by sine x, I get 2 sine squared x plus c sine x. And that is now my final answer.